Alright, let's look at the homework 10.4, problem number 9. Alright, so we're going to use the basics list of power series for common function to find the power series for e to the x plus e to the negative x all over 2. So this is actually a hyperbolic cosine. Alright. Alright, so let's see. So let's do one by one. So we know that e to the x is going to be a summation. N goes from 0 to infinity, x to the n over n factorial. Right? So which looks like this. It's going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial and so on, right? Then if you want e to the negative x, all you have to do is replace x by negative x. So it's a summation, n goes from 0 to infinity, negative x to the n over n factorial. Right, this is going to be, so it's going to actually, sign is going to alternate. It's going to be 1 minus x plus x squared over 2 factorial, and cube will be minus x cubed over 3 factorial, plus x to the 4th over 4 factorial, and so on. All right, so if you add these two guys together, right, we're going to get this, right? So we're going to 1 plus 1 is 2, right? But the x plus negative x cancel out, so these guys actually cancel out. Actually, I'm gonna let's see. Yeah, I'm gonna do this. All right, so I'm gonna actually pull out 2 here. So we have e to the x plus e to the negative x. Right, so it's a 1 plus 1, so it's going to be 2, right? And these cancel out. Again, we get 2 of these guys, so you have x squared over 2 factorial. And the next one, these two guys cancel out because it's the same thing with different sign. And the next one is x to the 4th over 4 factorial. Right, so you can see that you only get the even powered one. So next one, we know that it's going to be x to the 6th over 6 factorial and so on. All right. Then what we do is we divide through by 2. Right. So divide through by 2, which means that we can cancel 2 here and 2 there. Right, so you have a power series which looks like this. So it's a summation, and it goes from 0 to infinity. Right, so here it's always have the even power. So you have x to the 2n power, because if you put 2n, then it's only go through even powers, and divide by 2n factorial. Right, so that's the expression. So let's type it in. Right, so we have, so this is going to be a fraction. Right, then we have x to the 2n power over 2n factorial. Right, so let's check. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.